one can be done in Desmos. This one can be done in Desmos, but it's just easier because we have a graph. So we'll do that on the graph. And then 5, we can use the graph for that one. First, we briefly talked about this before, how to read this. We'll be talking about that again later. But if you look at which x connects to which y, that will help you. And we can put this into Desmos and a table. So -2 goes to 1. 3 goes to 0. 7 goes to 1. And 7 also goes to 4. So if I'm looking at these points, I see they don't go through a line. They don't make a line that goes through the origin, so they couldn't be direct. They make a curve, but not the curve we want. It doesn't do the hyperbola curve, so it's not inverse. But also, if you check the multiplying for inverse, you wouldn't get the same thing. If you divided y over x, you wouldn't get the same thing for direct. So it is neither. Questions on that? Number 3 could be done in Desmos, so I'll explain how in a moment. But if we were to write the equation of this line, we can find the slope from the given graph. If it were to continue, this would have a -2 slope. And then if I keep going with that slope, I should end up at -2 on the y-axis. And that would be your equation. If you wanted to do this one in Desmos, you would have to find a point that this goes through, put that in Desmos, type in your y equals mx plus b, and then change the m value to be -2 and move the b value until it goes through that point. So you could do that, but it's easier because you just have the graph to just go backwards. Questions on that one?
But it said don't make a y. Oh, never mind.
Yeah, so I was saying don't just randomly make a
I thought it meant like don't put it down. Okay.
Alright, number 5, if we plotted these 2 points, 0, 3, and -2, 4, since we're given a graph, I plotted that wrong, I can find the slope and y-intercept from that. Slope would be -1/2. And I know my y-intercept is already 3. So my equation would be y equals -1/2 x plus 3. Questions that you look confused? Okay, take out your notes from last class.
Why do you do this?
You guys practiced this page yesterday? Yes. We went over questions that you guys had. Some left, I don't remember. So then we're going to go, do we have any other questions before we move on? So with this, you have like bases, you also have numbers you can divide. You have a choice. You can either get rid of the 0 exponents first and then deal with whatever's left, or keep them and deal with them as you're subtracting or whatever. That choice is really tricky. So if I'm dividing, 2 divided by 4 would give me 1/2. These are backwards, but if I have 4 in the numerator and 0 in the denominator, I'm subtracting. So that would be a to the 4th. I have b to the 1st minus 4, so b to the negative 3. C to the 0 just becomes 1, and it doesn't have a like base to combine with, so that just disappears. So then if I were to rewrite this, a to the 4th is going to go in the numerator, or going to be in the numerator. B to the negative, b to the 3rd is going to be in the denominator. So a to the 4th over 2b to the 3rd. Questions on that one, or other questions on this one? Did you need another one?
I think so. Probably. Is that scary? What? Oh, there. Right there.
Alright, go on to the next page.
How does it taste?
What do you? Yeah.
Leave it alone for like 30 seconds.
So these are some of the ones that we've seen before, but a combination of more things. So I want you to look at just numbers 1 through 8 first. Which of those do we want to see, do, go over, have questions about? Number 4. 4. Any others? We'll start with 4. If we have other questions, we'll go into that. So 4, I want you to tell me what operations you see. We are dividing, yes.
Subtracting.
We will be subtracting the exponents. We will be simplifying, but that's not really an operation. What else? We will be adding the exponents, but what do we see right now? We see dividing and multiplying. So the multiplying is going to tell us if we had like bases next to each other, we could add the exponents. The dividing tells us if we have like bases, we can subtract the exponents. So we can actually divide 5 over 20. What would that give us? 1/4. We're subtracting the exponents. 8 minus a negative 2. What would that new exponent become? 10. And then remember that this is 1. 1 minus 6, our new exponent would be negative 5. And then you just rearrange. Move the x to the 10 up and the y to the 5th down. X to the 10th over 4y to the 5th. This thing is in the way.
Wait, how do you get 1 over 4?
5 over 20. And you don't necessarily have to do this step before this step. You could put x to the 10th in the numerator to begin with, and maybe you want to figure out what this is and then put it underneath. If you combine some of those steps, it's okay. But the questions, the operations, those are things you need to be thinking of when you see problems like this. What other questions in those 8 do you want to see, do, go over, have questions about? I'm not sure. Now would be a great time to ask. bottom ones. Numbers 1 through 5. Any of those we want to see, do go over, have questions about. Any others? And number 3, what operations do we see? Multiplying, and what else is happening? Not dividing, but there's something else going on. Yes, we will be multiplying the exponents, but because of what? Because what's happening? Because we're multiplying these together short, but something else is happening. We're raising exponents to other exponents, so we will be distributing multiplying short. So then, to get rid of those, multiply that to the exponent inside. So a to the 15, b to the 10. Remember to do this to any exponent you don't see also, so also to the 4. So now 4 squared, a to the negative 6, b to the 12. And then, what would be our next step?
Combining
Adding what?
The like.
We can add the exponents, not the like terms, of the like bases. So if we add them together, a or 15 minus 6 would give us 9. And then if we add our b's, 22. Are we finished?
You have to order.
You gotta do 4 squared. So I already put it in the correct order. 4 squared is 60. So 16, a to the 9th, b to the 22nd. This is a really good reason why we don't want to keep expanding. Because imagine writing out 22 b's. It's a lot. Okay. Questions about that? Okay. Number 5. What operation do you see there? We are multiplying. We will be distributing the exponents because we're raising an exponent to another power. And we're dividing. So what should we do first? Multiply the exponents to the other exponents, yes. Deal with that first because we can't divide with the parentheses still there. So we have 3 to the 4th, a to the 12th, b to the 16, all over 9a to the 5th, b to the 9th. And then we're doing what? Dividing what? Okay, so we can actually divide this. You have a couple different choices here. You could figure out what 3 to the 4th is, divide it by 9. Or you know that 9 is the same as 3 squared. You could change it to be 3 squared and then subtract the exponents. You have choices. If we were to just go ahead and figure out 3 to the 4th and divide it, what is 3 to the 4th? 81. And then we're doing what with the exponents? Subtracting. So 12 minus 5 would give us 7. 16 minus 9, also 7. We divide 9. So 9a to the 7th, b to the 7th. questions on that one? Other questions in this section? Sorry, there is some people still writing down. I have not shown this, but if we were to take any of these original problems, put them in Desmos, maybe it has an A and a B and you add sliders, maybe it has an X and a Y and you make them capital and add sliders, and put in your final answer, you should be able to see, did you get the right answer or not. So we'll do that with number 2. Okay. 2 is like 3, but we're dealing with some negatives in there. And we just have variables. So what are we doing with these exponents? Multiplying, because we're raising an exponent to another exponent. So x to the 6th, y to the negative 4th, x to the 15th, y to the 12th. You could keep them in parentheses, you don't need them. Combine them how?
Adding the exponents.
Add the exponents. So what would the exponents become? 21st.
No.
8.
Oh.
So you had a negative exponent in there. If you had moved it to the denominator and then you had y to the 12th over y to the 4th, you'd still be subtracting and you would still get y to the 8th. So it doesn't matter if you change it now or change it later. I would say waiting until the end to change it might help you, but it doesn't. Other questions on that one? Look at the back. There's 3 more, I believe. Questions on any of those? 2 of the 6 and 7 are similar to the 2 we just did, but we can still do any of those. And then 8.
Can you do 8?
Sure. In 8, what should we do first? So you have choices. You could multiply the exponents first, or you could subtract the exponents inside to get rid of like bases. Either or. So if we want to multiply first, that's what I meant first. So we'll do that. So 8 to the 3rd, c to the 27th, d to the 12th, over 4 to the 3rd, c to the 15th, d to the 18th. And then start subtracting. We also need to change both of these and figure out what those are. So what's 8 to the 3rd? 512. If we're subtracting, what would our new c value be? What would our new d value be? The exponent value, -6. And then 4 to the 3rd. So we need to figure out if 512 over 64 can be simplified, or can give us a whole number, and we also need to move the d down. If you divide it, you just get 8. Is that what you do? So then 8c to the 12th, d would be in the denominator.
So you move d back down.
If we had done what's inside first, we would have got a -2 and multiplied it by 3 to get the -6, and then still would have had to move it down. So either way, you would have got the same thing. This one. Because we changed it, we used our negative exponent rule. So anytime you flip it, it becomes positive. Other questions? Or questions on the other 2? So Now, you should be able to do the other Delta Math that is due tomorrow, the simplifying exponents, because you know all the rules. If you need help with that, you have some time in class, so I want you to try working on that. Working on the 2 Delta Maths. You can also come see me after school today. But hold on to this because we'll be continuing these notes, doing scientific notation tomorrow. But you have this time to practice.